Welcome to Crash Course. Today we're going to be talking about science, specifically about asbestos, a toxic that many people don't give enough credit to. What are asbestos? What are they made of? And what do they do in our environment? Let's just jump right in and find out. So what are asbestos used for? Asbestos occur naturally in nature. It's a group of 6 fibrous minerals. Their strong characteristics make them applicable and perfect to use in industrial applications. They are heat and fire resistant, highly non-combustible, have a lot of tensile strength, and they can hold up against chemicals really well. Due to these desirable properties, they are used primarily in building materials, such as roofing shingles, paper products, packaging, coatings, and many more.
Here's a diagram showing all the parts of the house that asbestos can be used for.
So what are the chemical structures of asbestos? Basically, asbestos are hydrated silicates in a fibrous form that's seen very cotton-like. They are divided into 2 subclasses of fibers called serpentine and amphibole fibers. These fibers are what make asbestos have their desirable characteristics, as both these fibers are resistant to heat, have a strong tensile strength, and have length to width ratios of more than 3 to 1. There are numerous kinds of asbestos which have different chemical formulas to one another. Chrysotile is a serpentine mineral, which is the most common asbestos fiber. It has SiO4 tetrahedral layers and MgOH2 octahedral layers. Amphiboles are different. They are usually massive, and their most common identifying feature is cleavage. This cleavage is along planes that are parallel to a z-axis. There's a 55-degree angle between both planes. Because of this cleavage, the amphiboles break into particles that take a shape similar to needles. So what class of toxins are asbestos really in? Well, asbestos actually has its own class of toxins due to the fact that they have 6 different kinds of fibrous minerals. These minerals are chrysotile, crocodylite, amosite, amphipholite, tremolite, and actinolite.
So this is a diagram showing the 6 different chemical formulas for each type of asbestos. So you have like the 2 main subclasses, serpentine and amphibole, and then the different chemical formulas. This diagram kind of shows the cycle of asbestos in the environment. So the sources of asbestos include like asbestos-bearing bedrock, materials used for roofing and water pipes and mining, and these can get into the water supplies or streams, lakes, and oceans, and then these can get into the atmosphere, and then they rain down as rain and snow, and asbestos and dust can also affect human health.
So how are asbestos introduced into the environment? Well, asbestos fibers actually transport very easily. They are able to travel through the air, through mining and processing, and are also able to enter the air and water through natural processes as well. When deposits and manufactured asbestos products are broken down, asbestos get released into the environment.
Asbestos cement pipes, as shown in this picture, are another huge threat to our environment and introduce asbestos more easily into our water supplies.
So what's the risk? There are many concerns associated with asbestos as of now, but the biggest concerns involve the type of fiber, size, shape, dose, and durability. So are asbestos a threat? Well, asbestos do have the ability to pose both a present and future day threat to our environment due to their capability of damaging water supplies and infiltrating the air. But as of now, a majority of their research has proven to show that the direct harm is to humans as a result of asbestos present in the environment. Though asbestos go into the water and air supplies, the environment itself is not harmed, but humans get affected as a result of the contact with the environment where asbestos are present. Plant and animal growth has also been seen to change with exposure to asbestos, and in some studies, animals show similar symptoms as humans do when exposed to asbestos with damage to their lungs. So how long do asbestos stay active in the environment? Small asbestos fibers remain intact in both air and water and atop of soil. They do not break down or biodegrade. They can travel by wind and water for a long time before settling down, and larger asbestos fibers settle down much quicker. Chrysotile, the most common asbestos, does lose some of its minerals when exposed to acidic environments, and it has been found that some asbestos fibers are able to break into smaller pieces, but they still do not biodegrade. How easily do asbestos move? Well, the contaminant is easily able to move between air, water, and soil. Asbestos go from the air into the water. They also do not enter the soil, but they do rest on top of the soil layers instead. How do asbestos break down? Well, actually, as I said before, asbestos do not break down or biodegrade. They do bind to soil particles, but they rest on top of the surface so that they can be easily taken away by the wind or water. Habitats or species are affected. Asbestos affects plant and animal growth. Soil and plant ecologists have found nutrient imbalances and excess concentration of trace metals in plants. Habitats placed near large industrial areas are very prone to inhaling or consuming asbestos particles, and the animals who occupy those areas face internal problems with their lungs, and they are not able to grow as big as expected for their species.
What are the symptoms of exposure? Long-term exposure to asbestos over 20 to 30 years can increase the chance of lung cancer, mesothelioma, and asbestosis. Symptoms include difficulty breathing, non-productive cough, fatigue, wheezing, chest pain, and cyanosis. In advanced stages of cancer, there may be weight loss and blood in the cough. So what is the approximate toxic or lethal dose of asbestos? What is the toxicity of asbestos under standardized conditions? Well, in most cases, humans are exposed to asbestos in their air and water supply, but it's in very small amounts that don't really affect their health, like ranging from 0.000001 to 0.0001 fibers per cubic milliliter. And in buildings, it can be around 0.1, and in mines, it's higher. We weren't able to find an exact LD50 value for asbestos. The data was not really available because it's hard to test for the LD50 value because the symptoms for asbestos usually they do not appear until many years after exposure, like 20 years after, so testing that would be kind of hard. Are some life stages, such as the young or the old, more sensitive than others? Children may be more sensitive because they are more likely to eat asbestos-contaminated soil and drink more fluids, per kilogram of body weight. Asbestos may also be found in schools. However, symptoms do not appear until later in life, up to 40 or more years later. Usually, industrial workers and miners are exposed to asbestos over a long period of time, and they develop asbestos-related diseases later in adulthood. Are its effects synergistic or antagonistic with those of other environmental contaminants? There is greater risk of lung cancer for smokers exposed to asbestos because there is synergism between asbestos and tobacco. What regulations or laws exist to control its use or application? Asbestos use has decreased since 1970 because of regulations from the Environmental Protection Agency, the EPA, and the Occupational Safety and Health Act, which sets limits of 100,000 fibers with lengths greater than or equal to 5 micrometers per cubic meter for 8-hour shifts and 40-hour work weeks for asbestos. In 1989, the EPA banned new uses of asbestos and set regulations for schools to reduce or remove already existing asbestos and regulate asbestos release during building demolition. It also regulates asbestos disposal by requiring them to be disposed in approved areas and asbestos in the preparation of drugs and food packaging materials. The EPA has proposed a concentration limit of 7 million fibers per liter of drinking water for lawn fibers. What are some possible substitutes for asbestos? Substitutes include fibers made of carbon, steel, cellulose, ceramics, and glass. Other substitutes are wollastonite and organic fibers made from aramid, polyethylene, polypropylene, and polytetrafluoroethylene. However, no single substitute is as effective as asbestos itself. Substitutes have been used for disc brake pads and drum brake lines.